Now let me introduce our guest for tonight. Parinaz Sobhani is the Director of Machine Learning on the Georgian Impact team and is responsible for leading the development of cutting-edge machine learning solutions for growth stage startup companies. Parinaz holds a PhD from the University of Ottawa with a research focus on solving opinion mining problems using natural language processing and deep neural network techniques. She has more than 10 years of experience in developing and designing new models and algorithms for various artificial intelligence tasks. Prior to joining Georgian partners, Parinaz worked at Microsoft Research, where she developed end-to-end neural machine translation models. She has also worked for the National Research Council of Canada, where she designed and developed deep neural networks models for natural language understanding and sentiment analysis. So thank you very much, Parinaz, for joining us tonight, and feel free to take over the streaming.
Thanks, it was great. Super excited to share AI trust, the area that I'm so passionate about with you guys tonight. I still adapting to this new way of engaging with audience, like by Zoom, and I feel like, especially because everyone is muted, I feel like I'm talking to a wall. So it's gonna be fun. So feel free to use the chat and ask questions and interrupt me. I will be more than happy to answer questions. Let's start. If you all can see my screen and you don't have any issue. So I'm gonna skip the intro because it was a great introduction, and I'm gonna but it's gonna be useful to give you a quick intro about our firm, Georgian Partners. We are a growth equity firm. We are the biggest private fund in Canada. And the main differentiation we have is that we are a thesis-driven investment company. We invest in high growth software services, enterprise software companies, but we only invest in companies that they have potentials for our investment thesis areas. And by investment thesis areas, we mean disruptive technology trends that they can revolutionize their market. And in addition to the investment team, as another differentiation, we have the impact team, where I'm coming from, the team of practitioners with background in software and academia who help our companies post-investment. Our main mandate and mission is to accelerate the growth and adoption of cutting-edge technologies and help our companies to build better products for their users and customers. Having said that, let's just move on to a quick discussion about artificial intelligence. I guess we are all familiar with AI, and you all know that AI has already moved from labs to businesses and consumers' applications. And of course, this is primarily because of advances in machine learning. Machine learning enables softwares to learn new things without actually or explicitly programming models to do that, and machines to do that. And the advantage is now we can tackle much more complex problems that weren't possible before. In fact, AI and machine learning can enable us to analyze and process very, very large amounts of data, both structured and unstructured, and emulate decision-making and augment humans or automate decision-making and business workflows. We published our pragmatic framework to assist adoption of machine learning for our companies, but you can feel free also to download it from our website. I really like our principles of our applied artificial intelligence because the main pillar here is a start with business problems, a start with the high value, impactful problems, rather than start from the data or getting excited with technology, which is one of the biggest problems I guess we have in current kind of data science kind of processes and teams. So you have to look for opportunities in your business to apply AI ranging from improved insights to full automation, and start with the highest impact rather than start by problems that might not have valuable outcomes for your customers and end users. And then the next pillar is integration. It is also one of the problems that we faced a lot, that we design machine learning systems and models without actually considering how these predictions and outcomes going to be consumed. As it's going to be consumed by another human or by another computer process. So you have to understand the role of people in your solution. They might be the sources of data, trainers, reviewers, or users of the predictions, and understand that there might be a requirement to have humans in the loop because of the market or regulation kind of limitations. And modeling is another conversation that has been one of the main areas of focus for most of data science teams, but unfortunately it's not the real world kind of scenario that most of the time we have to start dealing with lots of other problems other than the modeling by itself. And it's really important to be very pragmatic and start with more proven machine learning models because they are easier to implement, maintain, and also explain, especially if you're earlier in your journey to adopt machine learning and AI into your business. And finally, data. We all know that the main ingredient of machine learning models is data. And we have to understand if we have the sufficient and relevant data, or we need to start collecting some of these data, or we need to buy data from third parties. And finally, governance. That's going to be the main topic for our tonight's discussion. I will touch most of these issues such as errors, bias, fault tolerance, and of course, compliance and ethical decision making when you are building machine learning products. So what are the most important and biggest opportunities and challenges we are seeing today? Scalability. You might have heard about lots of people talking about scalability and increase in productivity. For example, there are systems now that can perform 100% of testing. Or another good example is e-discovery, automatic document classification that allows legal teams to classify tens of millions of documents. Consistency and reliability that was not achievable through manual approaches before. Lastly, there is enormous opportunity for creating more personalized, engaging experience for customers through the development of models and products at scale. They are all exciting, but of course, it doesn't come without challenges. Vastly increased data collections makes hacking more valuable, and it introduced lots of new issues around security and data and secure data storing and store data in transition and all these problems around security. The other problem is as AI is developing and evolving very fast, customer expectations are high and possibly unrealistic. There is also lack of education in terms of we are dealing with probabilistic models, and there is a kind of shift from deterministic systems to more probabilistic systems. And what would be potential requirements for algorithmic audit and predictions now need to be explained and validated, and we need to set the expectations on, given that we are dealing with probabilistic systems, we might never get to the 100% accuracy. Transparency, another issue. as we are developing more advanced techniques, as we are adding more complexity to our systems, the importance of transparency and explainability is even higher. The other issue, especially for people in this field that are building products, is like unpredictable nature of the regulatory landscape, especially in Canada and US, because we don't have any regulation in place. And of course, adoption of and skepticism, as similar to any new technology, there are going to be lots of skepticism, and kind of people might not be super receptive of using new technologies because they have various concerns. That's why we believe trust is an opportunity to add value and differentiate in this kind of environment. And according to the state of AI, a few issues that people thought about when they think about likelihood of like issues that can impact large numbers of people in US in the next 10 years. And of course, the other part, the y-axis, is all about what are the importance of these issues currently. The main kind of concerns are about privacy, security, fairness, and transparency. And people are skeptical with good reason, because breaches are increasingly common. Companies are not transparent when things go wrong, and technology is not there yet. And technology cannot address some of these new challenges. Of course, it's like it's rapidly evolving area. There are lots of research, active research, both in academia, in applied research labs, and in industry going on. And we are all more aware, and we have more awareness around these issues, and we are actively looking for technology to actually help us solve some of these issues and address these challenges. So if we look at like 5 years ago, 10 years ago, it was all about how we can collect large amounts of training data for specific problems and domains to be able to train our machine learning, supervised machine learning models. Now it's not only about how we can collect large amounts of data, it's also about how we can correctly label them and find relevant and unbiased and representative data. If it was only about finding the right method for efficient training of high accuracy models, is now about optimizing a combination of methods and tools for a specific use case. And if as part of the system, AI system requirements, we had high performance, now we have lots of other new requirements, such as fairness and transparency and explainability of our models. And it's not simply about let's collect more data, it's also about how you can build this relationship of trust to give some level of comfort to your users by providing some level of privacy, and give them more transparent data ownership, and communicate clearly how their data are going to be used in downstream applications. I just listed a few out of many other applied research areas in Trustworthy AI. These areas have been areas of focus for our team as well. Applied research areas such as differential privacy, federated learning, automatic bias detection, fair model and data, post-hoc interpretability, and transparency. These are the topics I'm going to discuss more tonight. Some of the use cases are more clear. For example, how we can, of course, differential privacy is about how we can build private machine learning models, but also how we can enable enable data sharing and data aggregation, and such as having some kind of win-win scenario. Providing better personalization by federated learning while not breaching any privacy, and also explainability can also help us with fairness. We know machine learning is all about correlation, and sometimes we are looking for like causality detection, and explainability also can help us to get closer to causality. And as developers of these systems, we like to have tools to enable us to debug our models and find potential bugs. Again, explainability can be hugely valuable for debugging of our machine learning models. I'm gonna pause, sorry, and make sure that there is no questions. I can find. Okay, just let me know if there is any question. I'm gonna continue.
There is one question.
Can you read it for me? I can't see
Yes,
the question for some.
So it's from Jim Miller. What is being done at the data origination stage to ensure that the raw data, before data science tools are applied, is of the highest quality, meaningful, and more available, applicable for insight generation?
I just want to make sure that I understand the question correctly. So it's more about how we can process data to make it ready to be used and consumed by machine learning models. Am I right?
Yeah, so what is being done to be sure it is of highest quality, meaningful, and more available, applicable to the insight generation? So yeah, how can we see that the data is good quality as opposed to maybe bad data?
Yeah, that's a good question. One of the biggest problems we have in machine learning, they call it garbage in, garbage out. If you don't, again, the main ingredient is data. So if we don't have a good quality data, if our data is biased, if our data is noisy, then the likelihood of building bad models is pretty high. So that's why I said the reality of data scientists' lives are not about playing with advanced modeling techniques. It's more about playing with data and understanding data and make sure that they have the right data, relevant, unbiased data in place. And it's not an easy exercise. I'm going to touch this topic again when I'm talking about bias detection and fairness. It's not an easy problem. And the reality of real world data is that there are going to be lots of missing values. There are going to be noise in data. It's all about how you can process data to improve the quality, but at the same time, it's also about how you monitor the performance of your machine learning models and having quality assurance, machine learning specific quality assurance to make sure that you are deploying the models that they have certain level of performance and they meet your kind of target level of performance before deploying it. And if they don't meet your targets and your requirements, then you have to look for new sources of data. You have to use similar inference in machine learning and statistical models to fill those missing values, to try to denoise data. But there are, but at the end of the day, we are not magicians. I always say data scientists are not magicians. They have certain powers and they have certain tools. But if data is garbage, there is no way to extract meaningful insight from it. Hopefully, I answered the question.
That is all the questions for now.
Cool. So let's move on to differential privacy. Differential privacy is like area that I'm so passionate about. I believe it's going to have lots of applications in the future. And privacy in general is an important topic, especially now that there are lots of concerns about contract tracing and using individuals' data to enable governments to better control this pandemic. And lots of people ask such questions. Is it possible to do it in a private manner? Is it possible to get the utility out of data, given that we are lots of devices are collecting data while not breaching any privacy of the individuals? And the answer, at least I believe technology has enabled us so far, like even now, to be able to get the utility out of data without breaching the privacy of individuals. And differential privacy is one of those technologies, a group of technologies, not a single technique, it's a group of techniques that can enable us to do so. it's a probabilistic framework to measure the level of privacy of a mechanism or algorithm that use data and provide an answer based on some computation on data. It's just very generic. So it's not only about machine learning, it can be about any benchmarking, any statistic, any kind of other data collection and understanding of the population. But of course, it's applicable to machine learning as well, because machine learning is also about computation on data. There are many techniques, I'm going to talk a little bit about them, but one of the biggest challenges for adoption of differential privacy is it's very heavy mathematics foundation, which is actually also not only a challenge, it can be also a bonus for that, because it provides mathematical guarantees as well, but it's a little bit harder to understand. And I will, please bear with me when I'm walking you over a couple of examples and try to explain it in the best way as possible. But it has many implications and applications. For our companies that are more like SaaS companies, it can help them to address cold start problems. But for consumers applications, there are also advantages to provide better personalization. And of course, it can help you with regulation and compliancy issues that you might have, such as GDPR. So let's discuss what we mean by preserving privacy. That's the first question that we need to answer. And it might look very easy, but for example, we can say to protect the privacy of an individual. What does it mean to protect the privacy of an individual? It means that we shouldn't be able to learn anything new about an individual. Then it means like no utility out of data. So maybe we should rethink about our definition of preserve privacy and reframe it as, if we learned anything new about an individual that we wouldn't have learned the same thing if that individual was replaced by another random member from the population. I know it's a little bit hard to digest, but it means that we learn about the population, not about any individual. This is how we choose to define privacy. Let's have our example. And it's more about anonymization is not equal to privacy most of the time. So a company releases compensation data, and they have names, comp, and a few other attributes about individuals, such as their gender. And of course, there's going to be breach of privacy. So we're going to anonymize the name of the employees with random characters. But imagine that we have a third-party information that Alice is the only woman in this company. And then we have a query of what is the average compensation of women in the company? And the answer is going to be 18K, which is exactly breach of privacy. So as you see, anonymization is not easy, and it's based on certain assumptions about the availability of third-party data, which is very hard to have such any kind of assumption like this. That's why we believe in differential privacy, because differential privacy doesn't have any dependency on any other data sources, and it's more like it provides more kind of systematic mathematical guarantees about the privacy level of our computation on data. Let's have another example. It's my favorite example. Let me ask you guys a question. Have you ever cheated on an exam before? I'm sure you are not comfortable answering this question. So I come up with this process. Pick a random number X, but don't tell me what's the random number. If X is odd, answer truthfully. If X is even, pick a random number Y. If Y is odd, answer yes. If Y is even, answer no. Did you understand what happened? Actually, based on the kind of answers I got from you, I can have a good understanding of the population or people in this room with good confidence without breaching the privacy of any of you, because every single one of you has plausible deniability. So, for example, if 7 out of 10 people in this room said we cheated before, I have a good understanding of, in average, how many people cheated in the exams before without breaching the privacy of any single one of you. We achieve this by injecting noise. This process is all about adding noise to your answer to protect the privacy of you. So let's go back to our compensation example. Imagine we now have this query, so we have to add noise to our answer to this query. For example, we can have like adding noise, just generate a random number between minus 80K to 80K, and instead of, and just add or subtract it from 80K, and then generate the response. But it looks like we kind of adding too much noise and killing the utility of our data. And the answer is pretty useless because the magnitude of noise is pretty high. So there is always such trade-off between utility and privacy. And that's why we need technology to enable us to have a good understanding of where we should, how we should balance these two kind of trade-offs. And differential privacy, again, is like a mathematical framework. It's about probabilities or about likelihood of understanding anything, or back engineering our machine learning models to get access to the individual data that the models have been trained on. So basically, we want to train machine learning models that they don't have any like dependency to any single individual data. So if we replace any single individual data and add a random number instead, it doesn't change the kind of weights or parameters of our models significantly. So the other advantage of differential privacy is that it helps us to have a measure of privacy as well. We call it epsilon. It is about the level of privacy, and it's similar to our kind of machine learning models performance. For example, we have accuracy, we have F1 score, and it just helps us to have an understanding of where we are in terms of the performance of these machine learning models. And epsilon is similar. It helps us to understand what is the privacy level of our machine learning models. And we can, based on the problem, the use case, and the sensitivity of data, we can have more privacy or less privacy to have more utility. It might look a little bit complicated, and I do agree. It also took me pretty long time to have a good digestion of what does it mean. But don't worry, if you are a developer, there are lots of open source tools and libraries. We also open sourced our software for building private machine learning models, and you can find it as part of TensorFlow privacy. Federated learning is another technique that can enable training machine learning models without sending data from local devices to the cloud. And it can help us to reduce the privacy risk by having decentralized training or active sampling. I don't have more than 15 minutes, so I'm going to just move a little faster because there are 2 more topics that I really like to share with you. One of them is fairness and bias detection. And it is a difficult time for many of us. And fairness in machine learning is actually one of the most important topics. And I believe every single one of us, we need to think about it. And it can change the future of many individuals and impact them or perpetuate all the kind of biases we had in human historical kind of behaviors. We can have racist or sexist machine learning models, and the level of impact going to be much higher than having individuals that are racist or sexist. So fairness detection, bias detection and fair test is one of the technologies that can enable us to understand if there is a potential bias in our system. And it's not, again, easy problem. Similar to differential privacy that we talk about, it's not simple, it's as simple as anonymization. Fairness is not also an easy problem. Removing sensitive attributes from a model does not solve the issue of fairness. My favorite example is your social media, like your favorite social media. For example, you might feel, okay, it's not a sensitive information if I'm a user of Facebook, Instagram, or Pinterest. But if your answer is Pinterest, with very, very high likelihood, with very, very high confidence, I can say you are a white woman, which is exactly kind of breach of your sensitive attributes or membership to more sensitive groups. So it's very, very complicated. There are, of course, biases are coming from many processes and data we have in our businesses. And it's not easy to identify such bugs. I call them bugs because I believe fairness and bias bugs are very similar to any other software bugs. They are not, or maybe they are more similar to security and privacy bugs, that they are very hard to identify. And it's not that easy to say, okay, let's have humans to evaluate the predictions of our models to figure out if there is a bias or not, because we know that humans are actually the source of bias. And there are many kinds of, many types of bias in sampling strategy, bias in presentation, bias in labels. So it's really important to, first of all, define fairness. And there are even many different definitions for fairness. And I was reading an article in HBR that actually, it might be actually a good opportunity for our society, because in machine learning world, everything should be formulated as a mathematical objective functions, as a mathematical equations. And fairness is such a kind of ill-defined or vaguely defined that we can't really easily frame it as a kind of mathematical equation. So it's kind of pushing us to have a better definition for fairness, and prevents discrimination against individuals because of their membership in certain groups, because of their color, because of their religions, because of their gender, because of their ethnicity. I used for one of our engagements and projects, we used fair test. It was a very useful tool. I would recommend it as a starting point to try that. And it's all about how we can identify those kind of unwanted, unwarranted associations between the errors of your model, for example, or between any other predictions of your models and any sensitive attributes. You don't, basically at the end of the day, you don't want to have certain micro segments of the population who are impacted negatively by the predictions of your model or by the errors in your model. One of the kind of projects or engagements that we had with our software companies, with our startup companies, was authorship attribution with Trinity. They provide softwares for K-12 and K-12 institutes and universities for plagiarism detection and contract cheating. And it's all about using NLP. It's all about using their kind of authorship styles. And it wasn't about using any students' information, any demographic information, any information about the performance of the students in the course, or but still we had concerns about if our models might be biased against certain microsegments. For example, if the model is picking certain patterns about non-native speakers, and it might be because of several reasons that, and we know machine learning is about correlation, not causation, so it might happen. And again, it's also related to the discussion of we need to have more diverse teams to work on AI products, because you might have guessed, I'm not a native speaker, so that was one of my concerns. How about, because I'm making grammatical mistakes, models pick those kind of grammatical mistakes as kind of signals for plagiarism, because it's about correlation, because there might be more instances of having plagiarism or contract cheating for non-native speakers in the training data because of our sampling strategy. So we run some tests, we identify potential issues, and we could actually, because we run all these tests, we could actually address those issues and proactively detect and correct biases to protect the students and deliver fair and objective evidence. Finally, I want to discuss transparency and explainability. But in the machine learning literature, the term interpretability is ill-defined, and it refers to more than one concept. In order to answer the question of what is interpretability, maybe it's better to first answer the question of why is it important or required, and what kind of problems we want to solve using interpretability and explainability. There are many problems that we can solve. Just give me a second. There are many problems that we can solve by interpretability, like building trust, safety, informativeness, regulation, and many others that I discussed a little bit in previous slides. But interpretability has been defined mainly in the context of transparency. How does the model work? And post hoc explanation. What else can the model tell me? Post hoc interpretability is super interesting topic, because the main advantage is we can provide more information about the model without sacrificing the predictive performance. 5 years ago, if you started to talk about interpretability in the machine learning community, everybody were against it, because they didn't want to sacrifice the performance of machine learning models. And it was more like, if you want to have interpretable models, you have to use decision trees or linear models. And we know that we can improve models significantly by using more advanced techniques such as deep neural networks. And it's all about several nonlinear layers of transformation on data that are not understandable for us as humans. And it's not because they are black box. I don't believe there is anything as black box. It's more because of our kind of limitation it's more about our cognitive limitation, and we can't process such information as humans. But don't be disappointed. There are several techniques and technologies that can help us to build and provide information about how those models work and how those predictions are generated. For example, LIME is one of my favorite approaches, and more advanced ones that have better mathematical foundations. JAP values, but pretty similar concept. It's all about local interpretability, and it's about let's have that nonlinear transformation that we don't understand, and let's build something that we can understand. It can be a set of rules or decision tree or whatever that helps users or end users to have a better understanding of models' predictions. I think I don't have enough time to get to the details of that, but it's about perturbing the inputs perturbing the inputs around this neighborhood and see how the model's predictions behave. We have the example here. For example, these are target of interest. You want to know why such prediction has been generated for this instance. We're going to perturb inputs around it, and we're going to build a new classifier, which is linear, understandable, and even the feature space might not be similar. So we might have several features or instance or attributes or predictors that are not interesting for humans or relevant. for the purpose of using such explanations, then we can just have like a fewer instances. So let's move from the space of f function to g function, which is something humans are interested to learn more about. I really want you to leave this conversation with a few practical advices. One of them is set system performance criteria. It's also related to the question we got, like how we can understand if we have a right data, relevant data, if we don't have garbage, is by having a good understanding of how our models are working now, and having some kind of targets in our kind of product management process, to have user interviews, to have users feedback, to have a good understanding of what would be the level of performance that is desirable for them. The other important criteria is explainability criteria, and you have to again understand what are you looking for. Are you looking to provide better debugging tools? Are you looking to provide more information to your users? Are you using explainability more kind of scientific framework to provide information about causality? And then error analysis is such an important topic, and quality machine learning specific quality assurance, again, like a topic that hasn't been touched a lot, but it's super important. It's much more important than modeling techniques that you are using. And fault tolerance, it's very similar to any other software development kind of process, and building software products is all about thinking about what can go wrong and where and how prediction is going to be used. And if we need to have humans in the loop, if humans actually might be another source of errors, and we might need to think about other options. And last, we developed our framework and principles for earning trust and building the relationship of trust with your customers and end users. It's beyond AI. It's not only applicable to AI and machine learning. It's beyond AI. It's all about the main pillars are similar to trust in AI: fairness, transparency, privacy, security. But of course, we're going to have accountability as another important pillar, and reliability, which is about deliver the result you said you would deliver. Thank you so much. I can stop sharing my screen so I can read questions, hopefully. I can figure it out.
You might need to stop sharing. You're still sharing.
Yeah, I have issues with my laptop. I don't know. Okay, cool. Okay, so most issues with data sharing comes from organization not wanting their competitors benefiting from their data. How would differential privacy help with that? I guess I understand that you don't want your competitors to get access to your data, but if you can reframe the message as a kind of win-win scenario, that is not going to be only your competitors who's going to take advantage of and benefit from data sharing, it's going to be also you. So if you can improve the performance of the machine learning models for all the kind of stakeholders, for all the partners, then it might be an easier. But if one of them gets more benefit, or if one of them gets no benefit, then it's going to be, of course, more difficult conversation. Is there any indication that introducing constraints like fairness and transparency can lead to reduced effectiveness in AI methods? Effectiveness, if you mean models performance, then again, it depends how do you define transparency. If we are talking about post hoc explainability, then there is no, you can have your training models and you can have any training models. There is no kind of limitation in terms of choices in machine learning models, but at the same time, you can achieve transparency. And then fairness, there might be, because if you especially remove certain attributes and features from your data because you believe there are sensitive attributes, as you remove more features, you might get the utility out of your data and machine learning models. But there are other techniques and technologies that can help you. For example, building fair representation, which is about how you can have two objectives. One of them is improving the performance and the other one is hiding the membership to certain groups. If you have historical data and you are training them, you get bias result, example, crime data. I guess, yeah, of course, I guess it's not a question. Shahram asked, how does the outcome of the method you introduce compare to adaptive Laplacian mechanism of preserving? Method introduced compared to adaptive Laplacian mechanism. It's, I guess, adaptive Laplace mechanism is very similar. Does the outcome method just compare? I guess it's going to be very similar. I guess there are, I guess we can also discuss, I guess we can have Laplace mechanism also in this category of differential privacy. So it's not a different paradigm. It can fall into the same category. How to continue with the challenges and opportunities to benefit from these, all terms of connecting others. I didn't get the last question from Abdul. If you can ask it, it might help me a little bit. I didn't get it. Dragas?
Yeah, I think that's all. These are all the questions for tonight. Thanks a lot.
Dragas, I have a suggestion for you. Next time, don't mute yourself or stop your video, because it's, if I get some noise, it's like any humans listening to me, it makes me feel better and I feel like people are engaging. It's really hard when I see nobody and I don't hear anything.
Okay.
To have sense of like I'm presenting something.
For sure. I'll do that. I'll make some noise. There's a
That's great. Yeah.
Looks like there's another question regarding training on historical data, how to remove bias.
Oh yeah, so Elnaz, I mean, it's not an easy problem again. It's super difficult problem. That's what I touched on. Like, there are again technologies, and there's an applied research area around fairness and bias detection. It's about how we can use optimization, similar optimization technique that we use in deep learning and machine learning, supervised machine learning, to kind of frame fairness as a kind of objective and add it to our objective function. So for example, having equal opportunity or having equal odds of error for different groups. So like rather than optimizing the model for the overall population, optimizing the model to have a similar performance for different microsegments.
Okay, a few more questions are coming, so we are not limited by time. So in case you want to answer or if you want to end.
Yeah, I can answer them. If your data is on a Yeah, the other issues that we might not have enough representative samples, Roxana, and for example, one of the issues we have in healthcare is that we don't have enough data from people of color, and normally the models makes more error for these people. One of the biggest issues we have, because we historically haven't collected enough data from people of color for various reasons. And it's not an easy problem, so there is no single solution. It's just about, first of all, identifying and acknowledging and recognizing there is a problem, there is such problem in your system, in the models, in your data. And then maybe one solution is actively looking to collect more data. That might be one solution. The other one is if you are sampling, and if you can use undersampling or oversampling to generate more data from those micro segments or subpopulation, that can be one solution. Joseph asked how to build AI trust with bad data or bad bias. Chatbot to say sorry. Yeah, I guess you're right. It might be the solution to transparently communicate that you have such holes in your data or you have such issues in your models. These are the issues that you are looking to actively to solve and address, but this is like the current state of your model. And over time, you might be able to, but I guess that's why I kind of emphasize on transparency and transparency in communication with your end users and setting the expectation. And then Abdul asked how to continue with challenges and opportunities to benefit from this, all in terms of connecting. I guess so. It's more about human augmentation, if I'm not wrong, Abdul. And it's about how we can, one of them is this relationship of trust that I touched a little bit. The other one is explainability. Why we believe we need to have explainability and interpretability is because we, as humans, we have our weaknesses and strengths, and machine learning models also, they have their weaknesses and limitations. At the same time, their strengths, they can process millions of data in such a short period of time. So that's why we believe it's all about augmentation. It's all about how we can have humans and machines interacting with each other and filling each other gaps. And Roxana asked again, do you think data augmentation for the populations where you have scarce data is appropriate? I've asked it for EEG data, but not sure that having data from 10,000 of people of color augmented to 100,000 of it. Yeah, for sure. Like, again, you touched on a very good point. There are, especially for ESG, I guess, there might be EEG, sorry. There might be opportunities to use data generation. I believe there are lots of techniques. Again, it's not an easy problem, and data generation is not an easy problem because you might introduce new bias to your model and to your system. You might introduce new errors to your system. That's why it's not an easy solution. But for sure, if you can come up with some kind of data generation oversampling, and I know it's not an easy, especially for EEG, to collect more data. So of course, it might help a lot to start with oversampling and data generation.
I think that's about it.
Cool.
Thank you very much, Parinaz, for the nice presentation tonight.